Question 1. Part A, state one disadvantage of using quota sampling compared with simple random sampling. Well, quota sampling is when you just grab the people that satisfy the condition that you're looking for and you fill up your groups with the first people you come across. So simply, quota sampling is not random, and so it can't be reliably used to make inferences. In a university, 8% of students are members of the university dance club. A random sample of 36 students is taken from the university. The random variable x represents the number of these students who are members of the dance club. Using a suitable model for x, find the probability that x is equal to 4, and then the probability that x is greater than or equal to 7. So we have a group of 36 people here who are either a member or are not a member of a dance club. This means we're looking at a binomial distribution. We have a group size of 36, and then the probability of them being a member of this dance club is 0.08, or 8%. Part I, the probability then that x is equal to 4, we can find on our calculator, which I will show you how to do now. And so if we go to number 7, our statistics mode on our calculator, we want to find the binomial PD because we're looking for one specific value. So number 4, we want to select number 2 for variable, and our x value is 4. That's how many people we want to find to be members of the dance club. The number of people in our group are 36, and the probability they are a member is 0.08. And if we hit equals, we get an answer of 0.167387, and so on. For II, we want the probability that x is greater than or equal to 7. Now remember, with a binomial distribution, the values are discrete, and so finding a probability of greater than or equal to 7 is the same as 1 subtracting the probability of all values less than or equal to 6. So this value we can find out on our calculator. Returning to our calculator then, if we go back to the menu and select stats mode, we want the binomial CD this time because we're looking for the cumulative distribution less than equal to 6. And so select option 1. We are a variable, so we want less than or equal to 6 now. Our n is still 36 and our probability is still 0.08. So if we hit equals, that's our probability of less than or equal to 6. Now our calculator will automatically store this number, so if we go menu 1 into the calculator and type 1, subtract our answer, that will take away the 0.97 etc. And so the final value we get is 0.022233 and so on. And hopefully I showed how to get the value 0.022. Only 40% of the university dance club members can dance the tango. Find the probability that a student is a member of the university dance club and can dance the tango. So this is a GCSE rule for probability actually, that if we have two probabilities, the probability of one and the other occurring is the probability of the first multiplied by the probability of the second. And so the probability you're in the dance club and can tango is the probability that you are in the dance club, which is 0.08, multiplied by the probability that you can dance the tango, which is 0.4. And this works out to be 0.032. A random sample of 50 students is taken from the university. Find the probability that fewer than 3 of these students are members of the university dance club and can dance the tango. So we have a new distribution here. Let's call our set Y. Again, we are distributed binomially because we have a fixed number of people, the students here, there's 50 students, and we've just calculated the probability that you're in the dance club and can tango. So given this distribution, we want to find the probability being less than 3 students, not less than or equal to, it says fewer than 3 students. And so that's the probability that Y is less than or equal to 2, which we can again put in our calculator. So returning to our calculator, let's go back to our menu, stats, into binomial cumulative distribution number 1 as a variable. Our x now is 2, our n now is 50, and our probability is 0.032. And that gives us a value of 0.785 and so on. And hopefully I've shown that we get the value of 0.785.